So we're going to look at this problem here, where we're going to use technology to help test the claim about a population mean at the given level of significance using the given sample statistic. Assume the population is normally distributed. So we have a claim that mu is greater than 1,250. We have an alpha of 0.06. So our level of significance is 6%, right? Our standard deviation is 210.69. Our sample average was 1,269.13, and we took 250 samples. So let me bring that over to here, right? So our claim is the alternative hypothesis in this case, because we're saying that mu is greater than 1,250. And so it's the alternative hypothesis because it has the inequality, which means that the null hypothesis is less than or equal to 1,250. So that sets up what we're testing against. So let me put claim here, since this is our claim. And then in our level of significance is 0.6, and our standard deviation is 210.69. Population 210.69. And we go and we take samples and we get 1,269.13, 1,269.13, and our sample standard deviation. Oops, no, not our sample standard deviation. I'm sorry, our N was 250. And so we want to test this claim, and we want to test it to this level of significance. So we look for the type of test we're going to have, and the alternative hypothesis points right. So we have a right-tailed test. All right. So we have a right-tailed test. Now our standardized test statistic will be a z-score, because we're testing a population mean with a known population standard deviation. So our z-score, and again, I'll go back into our technology here and let this do this for us. So let's see, I want to go to stat. Oops, I have to turn it on. We'll go to stat. We'll come over to tests and we'll do a z-test. Now in this case, our mu was 1,250. 1250, enter. Our standard deviation of the population was 210.69, 210.69. Our sample was 1,269.13. And our where is it here? N is 250. Sorry, I had to look at that. And our test statistic will be greater than. And we'll calculate. And so we get a z-score of 1.435. Put it here, and a p-score of 0.0755. So let me switch back over to here. What was it? Come on, come back. It's not, there we go. Yeah. So we had a z of 1.436 if I round up. And just to note, we had a p-score of 0.00756. All right. So we now want to find this critical value, z critical, and we want to see if we lie within the rejection region or not. So z critical is based off of our normal. So we're going to come back to our calculator again, and we're going to look at our inverse normal. And the area we're looking for is all of the area. So when we go back here, we're looking at a right-tailed test, and our alpha is 0.06, so we want 0.06. So let me come back here. .06, and our mu is 0, 1, and we're going to paste this in. We're going to get the negative side of this, negative 1.55. But this is a normal distribution, and so we also get the positive 1.55. And so I'll put that as my Z critical. It's positive 1.55. And so this is 1.55 is my critical value. Well, this is 1.43, so it lies inside of it. And so we fail to reject the null hypothesis, which means that there is not enough evidence to support the claim.